In front of you that handout that you have, and I'm going to put this here for our friends at home if anyone's absent today. That's for today and tomorrow. Please don't lose that. Right? I want to do front and back printing to help save paper, but this is for today, and then the back of it is for tomorrow. So if you don't have one of those, please come grab one. Wait. Do you have a handout? It's up on the TV. 9 to 13. So then 5-2, you want to keep reading, Sky?
Yeah.
We are going to be in 5-2 by Wednesday. So we might as well look at what we're doing in 5.2.
You will investigate probability using a deck of cards and a random number generator. You will learn to represent multiple events using a probability tree, a list, and a table. You will also revisit the idea of the fairness of events and compare experimental and theoretical probabilities.
So think about games you've played or things you've done where, like, you think it's not fair. And what fair really means, aside from the place with the rides and everything, what does it actually mean for probability of an event to be fair? So before we get there, we are starting in part to whole relationship. Who's ever seen a food label? I sure hope so. Who understands what the food label's telling us? Kind of. Ethan, you want to give like a quick explanation of like what's on a food label?
So basically, on the food label, it's like the different fats and fibers and vitamins that's in like the proteins and stuff that's in the food.
Yep, it's like the chemical breakdown of what's in your food. And here's the part that we really care about. Now, when I went to the doctor a little while back, actually, I think I was off of school for a day to go to the doctor, I got told that I need to reduce my intake of sodium. For real, like not making this up. So, I now am looking at all of these when I'm eating food, and there are certain culprits that have really high sodium in food, like canned soup. Often has a lot of sodium because it's been preserved, so it stays good in the can. They use salt to do that. So right here, if you're interested in this, we have, and actually, this might be the same food label. I think it actually is. This label's up here on the board. My wife was a phys ed teacher. I think this is just like a stock food label that they give us. So when we look at that percent daily value, that's based off an average person, right? So are you an average person? No, you're a kid. You're going through puberty, right? You're an adolescent. You're growing. Your body's changing. So you actually probably need more on some of these things than what a standard adult would need because you're growing, you're developing. You know, they always say, like, drink lots of milk and get those strong bones and the vitamin D and all that stuff. Yeah?
Something kind of like this, my brother, Shane, he does like a lot of running and stuff, so
Yeah.
he eat a lot. And then my mom was talking about how since he has to eat a lot to make sure he's not like gonna die.
Yeah.
Whenever his like metabolism, or she used a fancy word, like stops or something,
Yeah.
then he's just gonna be so used to eating a lot, and then like he's not gonna be growing.
Yeah, so your metabolism is actually the rate at which you process food. So if we look at a question like this, if we know how much vitamin C is in a serving, right, this up here says serving size is 1 cup, but the servings per container, that means that there's 4 servings in the container. So really, what does that mean there are 4 of? Cups. There's 4 cups, right? So if we know how much vitamin C is in a serving, what if I eat the entire thing? Whatever this is a food label of, if there is, well, how much vitamin C is in a serving here? So look at the label. 2%, right? If we follow vitamin C across, there's 2%. So now that's percent of your daily value. Not that 2% of the food is vitamin C, but if you eat the food, you will get 2% of the vitamin C that you need. So if I eat this entire container, if I eat all of the servings, what percent of vitamin C will I have? Casey?
8.
How'd you figure that out?
Because if it's 2% in one, you multiply it, so find something worth it for.
Yeah. Casey says if I know that it's 2% in 1 cup, and I eat the whole thing, all 4 of them, I got to multiply my 2% by 4, and I will have ended up eating 8% of my vitamin C. But then I've consumed 80% of the sodium I'm allowed to for today. That's almost all of the sodium, because if I eat all of this, right, times 4, I've consumed 80% of it. So you got to be careful with some things like that. All right, so let's move on to an actual question. So this label is for Cheesy Mac. Now, I know you're probably used to Kraft Blue Box or whatever, but I'm not quite sure which macaroni and cheese it is. But they tell us we have 15% of our saturated fat. Now, there are different types of fats, right? They actually can separate the types of fats. You need something to use hanging out. Yeah, so we're talking percentages really, but what's cool about how CPM does this is it ties together food labels and everything else. So we were just looking at this, which actually I have on my chalkboard. So if we have 15% of the recommended daily amount of saturated fat, and nutritionists recommend that a person should have no more than, well, we're not 100% sure what amount, but some amount, right, which we're going to calculate then. And one serving has 3 grams. So let's go back up and look at this. Saturated fat. 15% of what we're supposed to eat in the day. Or what we're allowed to, right? Kind of my limit. I want you guys to talk as a group. If we were going to try to figure out how much saturated fat we're allowed to have in total for the whole day, how could we try to figure that out based off this food label? So talk with your team. Maybe jot down a couple ideas. If this Cheesy Mac has 15% of what I'm supposed to be able to have, and that's 3 grams, how could I figure out the grams I'm allowed to eat in total? Go for it. I'll give you a couple minutes.
Do always get you is top
get that, and then multiply it.
like not eat the whole box. Yep.
Yeah, I gotta watch my sodium intake now, for real. Yeah, doc told me I gotta bring it down.
That's hard.
Yeah, blood pressure's too high.
It's in everything.
And the heart stuff I'm on, like, doesn't help anything, so.
The sodium's in like stuff you don't get salt in.
Dude, canned soup is really bad.
Oh no.
I used to eat a lot of that. What does percent mean? Out of 100, right? Per 100. All right, come back with me. Anybody have a really good idea that they want to share? We are on 5-1. We're back to problem 1, guys. Sky and I don't know if I'll be able to call on you the rest of the class.
Okay.
You're like running this
So
thing.
our group, like we decided that you could do 100 divided by 15, and we didn't solve any of it, but
100% divided by 15%. To what? What are you kind of doing here?
well then we were going to do 15, no not 15, the number that we got times 3.
So, if we do 100 divided by 15. Somebody with a calculator do this for us. Does nobody have a calculator? Thank you, please.
6 something.
You're like 6.666.
Yeah.
So 6 and 2/3.
Yeah.
Then that 0.6 repeating is 2/3. So then what did you say we were going to do?
Multiply that by 3 since there are 3 grams.
So that times the 3 grams. And we get 20 actually.
Oh yeah,
Because
then that would
2/3
be 2
of
and
3,
18
right?
plus 2.
It just happens to work out nicely. So in my head, that is not how I envision doing this. That's perfect though. This is absolutely perfect. In my head, what I think about is 15% means 15 out of 100. And what was the thing that related to 15%? How many grams? 3. How do I go from 15 to 3? Divide by 5. And if I do the same on bottom, I get my 20 grams I'm allowed to consume.
That seems a lot easier than the way I did it.
Well, so your way totally makes sense. What Sky was solving essentially is how many of these 15%, like, would I need to get to 100? Well, 6 2/3. But I just went a different way. Which actually all I did was flip it. You know, like you went 100 over 15. I went 15 over 100. Right? So I just set up my fraction in a different way. So 5-2. We are going to start to use line models to represent 100%. So in your notes, we want to get really comfortable with when we do this, that represents 100%. So go ahead and set one of those up. So here's what's up. The video will be posted. I run it slightly late, but I'm recording. It'll be posted before you ever get back here. So if you quickly want to watch through the rest of the video, like how many people am I losing? I know Aiden.
There's only 2 people.
Not that many choir people in this class. Okay. So if you have questions later, let me know, Aiden. This is probably too far. Anyone know what a partition is? Like tech people sometimes know because you can partition a hard drive or you can partition your computer. So this is good vocab application. This is a partition. A partition is anything that breaks things up. So if we wanted to partition this 100% line and try to approximate where 15% would be, would this make sense? No, way too far out, right? So on your paper, try to partition where you think 15% would be, and then we're going to notate that as being 15%. How many grams would go up here to correspond to our 15% amount? 3, right? If we're still talking about that saturated fat. Now, Sky, we're actually going to take your method here. If I ask you how many of these we need to get all the way to 100, we can figure that out through Sky's math. 100 divided by 15% tells me 6 2/3. So I would have to jump this to 3, 4, 5, 6, and a little bit more. So my drawing's not 100% accurate. But if that's 3 grams, and this is another 3, and this is another 3, and another 3, and another 3, to get all the way up to 100%, and then we have another 3, and then another 2, we end up with 20 grams at our 100%. I think if my math is right. 3, 6, 9, because this was 3, right? This first jump, that's how I got to 3 here. 12, 15, 18, 19, 20. So really, this is just to get you comfortable with the setup that we're going to be using. So if you look at your handout, all of those are 100% lines, right? So we're not going to use the back today. That's for tomorrow, so that's going to complicate things. So please keep it on the front, the one with just 3 of them. But that's how we're going to start to model percentages. Any questions on how we draw the little line to partition and split things up? All right, so some vocab reminder. Because I think some of us have overcomplicated this. Some of your questions from the mastery made me think about, like, do we really understand exactly what we're talking about? What's a ratio? If somebody tells me to set up a ratio or build a ratio or represent something with a ratio, Jalen?
It's like one number to the other number.
Yeah, it's just a comparison of 2 numbers. So I wanted to review this. A ratio is any number compared to another number. A compared to B. Whatever A is and B is, doesn't matter. Number compared to a number. Or we can even use variables in ratios. It's really just a thing compared to another thing. So if your parents ever compare you to a sibling or you to, like, that's actually a ratio. It's a comparison of two things. Yeah, like if they say Sky compared to Shane is twice as smart, that's a comparison, right? I doubt your brothers are going to hear this. I'm joking, by the way. But so a ratio is just comparison. Now, guys, a proportion is a ratio equal to a ratio. So if somebody asks you to build a proportion ratio equal to another ratio, right? Remember that. So ratio is just simple comparison. So when we talk about 15%, and somebody tells you to write that in ratio form, that's 15 over 100. Please have this with me. And then can I reduce those? Yeah. We always want to reduce ratios if we can. What can they both be divided by? Yeah, 5. So if I divide by 5 on top and bottom, we get the same numbers that we were just working with. My 15% was 3 grams, which means my 100% is 20 grams. So we can use a ratio to go from percent form to answer our unknown that we're dealing with, because all we knew were these 3 numbers. We didn't know the 20 at first, right? We knew 15% was 3 grams. If we want to figure out the 100, set 15 over 100, see how these compare. Questions? Because you're about to do this on your own. So in 5-4, check out that situation. You can go and read that with your team. You've got the diagram on your paper. So you don't even have to draw this in your notes. You've got it done for you. So go ahead and set this up. See if you can determine what is our daily intake of fiber suggested. What do you mean, ew? If you don't, that'd be even grosser. Have you never read the book Everybody Poops? It's a kid's book. Ava, I love grossing you out. All right, how much fiber do we need in a day? Make your body work right. Yeah, but what is 100%? It's all of it, right? You need all of it. Man, where's the fourth? Or there was no fourth king, was there? Where's your third? Oh, it's in the problem. Guys, the problem tells you more information than what I have. So is it just the 3 of you? Now you lost 2 to the choir. 16. Yep. Layla, if you want to jump in on the group for the rest of the class today, you can. We got like 20 minutes left, so I don't want you to be lonely the whole time. Where's the fourth? Oh, yeah. Your hands are full. Now, I will tell you, there are a couple different ways to do this. If you solve it one way, analyze, could you do it another way? Do the numbers work well together? So if you get your answer one way, I want you to think about, is there another way you could solve it?
So that would be 6 and 1 4. Will be 16. So 60% of 100% equals 6.25 grams times 4 grams. We that would be 0. That would be 24 to 25.0 grams. I got 25 grams.
Now, I was debating how to teach this. I don't care where you write your numbers, but CPM has their own structure. You need to make a choice. Are you going to put your number above or below the bracketed section, or are you going to put it at the end, like on the line where it cuts at the partition? I don't mind where you put your numbers. CPM puts them above the bracketed section, which makes good sense. It says in this region, under that, that covers 4 grams, and or that covers 16%. But if it makes more sense to you to put them at the partition, you may. Like, that's totally fine. You can leave them in both places. So you should have 16% somewhere, either below the portion or at the partition. Oh, I bought a new jacket this weekend. Can't wait to wear it.
Is it that?
It's a holiday suit jacket.
Ooh.
I got a whole bunch of new sweaters, but they left all the security things on.
Yeah,
They did that.
Did it?
They did.
Really?
That happened to me in the pools too.
Yeah. Whenever we went back, there were like 15 trillion.
All right. I want to know how you looked at this. So, Adrian, just tell me your first step. When you went into this problem, what was your first step? There's a lot of right ways. Okay, so what'd you get then? What percent is left over? 84. Yeah, so this region out here, Adrian first figured out this is 84%, right? Because 84 plus 16 makes 100. You okay?
No.
Okay, what'd you get?
50%.
How?
Okay, so I did 16% over 100% equals 8 over 50.
8 what?
So hold on. So you did 16 over 100, right, equals, what is our 16% here? What is our 16%? No, but in the problem, what is 16%? What value is it?
Oh, it's 4 grams.
4 grams, right? This should be 4 grams. But then you got to ask yourself, how do I go from this ratio to that ratio?
And then the bottom is 25 grams.
Yeah.
I was right. Wait, then why do you have 84%?
Because that 25 grams is our 100%. So that 25 goes out here. But what Adrian was giving me was how much percentage are we missing?
Oh, I put 100%.
So change that then. Because we know the whole bar is 100. So please make sure you're with me. Now, here's the dangerous thing. The missing region isn't 25.
Would it be 21?
The missing region is 21 grams. Because we found out 100% is 25 grams. We know what the entire bar is. Our 100% daily value, the fiber that we need for our body to be happy, 25 grams. Now, if you don't quite make it one day, eat more of it the next day, or like you'll start to feel it. Like if any of this, if you don't have enough sugar in your body, now for kids, you probably do, but you'll feel it. If your body doesn't, you like need to go eat an apple, eat an orange, eat a piece of candy, whatever. Anyone have another way to deal with that? Kevin?
What I did is that I did 16 times 10, I did 4 times 10, then I divided them both by 4, and then to get to 100%, I just multiplied the 40 by 2.5, and then I multiplied the 10 by 2.5. I got 25 grams.
You multiplied. So I'm trying to follow what you did. You said you multiplied by 10 first.
Yeah. For both of them.
Wouldn't that get me 160%?
Yeah, but then I divided by 4.
So hold on. Kevin took a really cool way. So Kevin multiplied by 10 and figured out that 160% would be 40 grams. Are you with us? You don't have to write this down, but I want your brain processing with us. Then, so hang on. So Kevin, then what'd you do?
Divided both by 4.
Divided by 4. So you found out that 40% is 10 grams.
And then I multiplied by 2.5.
And then he said to go from 40% to 100, I can multiply by 2.5. And he got his 25. There's always another way to go. You want to see what happens in my head? 16 and 4 work together really well, right? Like we can just see that immediately. So if I divide them both by 4 right off the bat, one thing that I heard Kevin say, divide by 4, I can figure out that 4% is what? How many grams? 1. Oh, look, it's a unit rate. I have 4% per gram, and that's a unit rate. How do I go from 4% to 100%? Times 25. Okay, look, my answer, 25.
That's so easy.
Always multiple ways. Look at... Oh, and then Adrian already answered this for us. What is 21 out of 25 here? 4. Careful. What is 21 out of... If I did that division, that's this region, right? The 21 grams that were up here. What percent was that region? 84. This should give us 0.84, right? 84%. Try number 5. Read what they tell us. Talking about carrots now. Read it in your head. We should be filling in our diagram. Guys, by the way, we are having a mastery next week before we go to break. This exact stuff is going to be on it. You would rather come back from break without a revision as opposed to coming back from break and immediately getting handed a revision to take care of. Yep, next week's the last week until break. Nathan, can you tell me one place to put one number up here? So if we look at this, the yellow highlighting, if our recommended daily intake, it's like all of it, right? We saying the 6 or the 60? The 6, yeah, the portion. So guys, right here, this question mark should be 6 milligrams, which out here, this question mark should be what? 6D milligrams. Please make sure you have those both labeled. Now, Ivan. That's what I was just looking around like, I don't think I've seen him today. Brendan, why did Risa divide her percent line into 10 regions?
'Cause 6 times 10 equals 60.
Because 6 times 10 equals 60, or we can flip it around and say like 60 divided by 6 is 10%. So since we split this into 10 portions, right, Ava?
Yep.
Yeah, I didn't ask the question.
I know.
Although I am wondering why you're talking to Adrian.
I wasn't talking. Okay, I was talking to myself, but I wasn't talking.
Okay, so I need you with me.
Okay.
So, Ava, what would be this portion, or what goes on this line, essentially?
Don't you have to do like
Gotta do a little bit of math. How many percent is the whole line?
60.
The
Oh,
whole
100%.
100%, right? How many percent did we take up?
10.
10. How much do we have left?
90.
Yeah, 90%. Now, take a moment, fill this in. How many milligrams more? Take a moment. Adrian, question or answer? Answer what goes here. Yeah, this would be 54. So 54 milligrams would be what percent? 90. How many milligrams? I'm going to throw you some other questions. How many milligrams would be 30%?
not very much.
18, right? If we think going right here, 6, 12, 18, that would be 30%, right? What about 50%? If a dish claims to have 50% of your vitamin C, what's 50%? 30, right? Half of my total, 50% is half. It'd be 30.
Whoa.
Forget what else we want to do on this problem. Okay, we'll point out the elephant in the room. Yes, I've changed how the power gets back to those lights. So there's not an extension cord, a power strip run across there. Guys, creative problem solving. I was, again, making people upset because I stole Mrs. Gordon's power. Binder clips, I realized, would be the perfect thing to hold the wire up there. So, they're binder clips. Where's the what? There's only ever been 2 lights. I bought them, trust me. There's only ever been 2.
I feel like 3 would make it
Nope.
look better.
No, y'all are crazy.
No.
All right. Now, if you have ever, who's my artists in the room? Have you ever tried to mix your own paint? Now, hold up. Have you ever tried to mix your own paint on day 2 to get the same color you had on day 1? Now, hold on. You said it never works. I'll teach you how to make it work out.
Measure.
You gotta have.
I'm not going to do math and I enjoy my time.
Sorry. You're gonna do math for the next 7 minutes. If you wanted to make the paint match, we'd have to make it exactly the same as before, right? Which is why my artist in here is saying it never works. Artists don't like precision normally. But if you're actually trying to make the paint match, you're gonna have to care. So Reese is mixing up purple paint. Purple is made of red and blue. So for the shade of purple she wants, here is her percent bar. Do we know what percent is blue? We can figure it out. So take a moment with your team, fill in what percent would be here, and what percent would be, and I'm going to make it red, what percent would be out here. Take a moment with your team, figure that out. Now you might need to start by saying what really is up here.
That's perfection.
But like, it'd be weird to get like
It works well together, doesn't it? wife might get angry. Guys, you have this on your worksheet. You can be writing on your worksheet if you want. Anybody, how many total parts? 15, right? There are 15 total parts. So 15 is my 100%. 15 is my 100%. Alright, so while I still have a couple minutes, I want to teach you a rule that always works. I guarantee it works. So somewhere make like a star or something special on your paper. Like this is the biggest thing for you to get from today's lesson. Star, smiley face, something.
I like stars.
To find a percent. To find any percent. This always works. All you have to do is part compared to whole through division, right? A ratio just tells me to divide. And then bump your decimal over 2 places. That times 100, and I would like you to make a note. All it does is move the decimal. So if we're trying to figure out what percent we have of blue, we want to put how much blue we have over our total. Well, how much blue did we use? 3. What was our total? 15. Now hold up. Work backwards before you work forwards. Can I reduce 3/15?
Yeah.
1/5. Can I think about that over 100?
Yeah, times 20.
Ooh, careful, times 20. So what should go below your 3 parts blue is 20%. Now hang on, because I've confused people in the past before, so I want to make sure I don't confuse you. Here, if I think about this actual number, it's 0.2. When you multiply by 100, it bumps that decimal 2 places, and that's how it lands right here. That's all that multiplication by 100 does. So if you in your head know that 0.2 becomes 20%, you don't actually have to multiply. You just have to know what you're doing. You have to move that decimal to put it in percent form as opposed to in, this is actually rate form, the decimal form. Questions? What percent would be red? 80, right? We know that from subtraction, but if you want proof, I would write this on your paper just to solidify it. My percent red, how would I set that up? What ratio? What ratio would I start with? Yeah? Yeah, red over total. So how much red? 12. How much total? 15. That actually becomes 80 over 100, which is 80%. Again, if I did the math, it'd be 0.8 times 100, which becomes 80. Or if I just know that it's whatever number over 100 is my percent, then I'm good to go. Now, if you want to exercise your brain, the only last thing that we were going to have is this additional challenge of Turner Middle School, which we don't really have time to talk about. But you will have homework problems like this, so be careful. Give me your eyes for one last second. Be careful on these problems. Sometimes they give you the whole and then one part of it, and then ask you about a different part. So notice this says Turner Middle School has 110 boys. 56% of the students are girls. What percent would that leave being boys? Well, how much more percent do you need to get to 100? So that's what you got to think about. Read carefully that 56% doesn't go with the boys. That 56% goes with the girls. we'd have 44% left over for the boys. And if you're a boy, you'd probably be okay with going to that school. All right. That's all I got. Have a wonderful day, guys.